slides off?
Yes, please. All right. Why did it not go back to presenter view? There we go. All right. Basically, all this first slide says that this is my work. I'm stealing from others, so it's a collaboration. And we're going to discuss the history of electricity, atoms and charges, the law of centripetal force, and the difference between conductors, semiconductors, and insulators. In simple terms, centripetal force is defined as a force which keeps a body moving with a uniform speed along a circular path that is directed along the radius towards the center. In other words, like gravitation is a centripetal force. Okay? History of electricity. Charles Francois Cisterna Dufay, or we just call him Charles Dufay, discovered basically that there was positive and negative. Of course, he was working with just DC because really and truly he was working with like a piece of glass and a cloth. You know, he wasn't working with real technical stuff. You know what I'm saying? He said there are electrics and non-electrics. He found that like charges repelled and unlike charges, in other words, a positive and a negative, attract. Dufay's observations got him into the National Academy of Science, and but the paper in the next year, 1735, I think it was, and his paper was written in 1734. Okay, the atom is the basic building block of the universe. The element is a substance that cannot be chemically divided into simpler substances. And the best known parts of the atom are the electron, neutron, and proton. Why do I say the best known parts? Because everybody's heard of those parts. You may not know what a quark is or a gluon or things like that, but those are possibly parts of an atom. But we're not going to get into that. We just want to talk about the three big parts that affect electrical stuff. Okay. You need to know these definitions. If they're not in your book, if you didn't see them in your homework, write these down. An element, although I'm pretty sure these are defined in your book. Element, a basic substance that can't be simplified, such as a single element like hydrogen, oxygen, and you know air is, no, water is H2O, right? Water is H2O, that's two hydrogens and one oxygen, so that's not an atom, it's a element. Okay? I mean, it's not an element, it's a molecule, sorry. That's a hydrogen, and two hydrogens and an oxygen bond together become a molecule. So an element is a basic structure that can't be simplified. It only has one type of thing in it. A molecule, two or more atoms that are chemically joined together, like water, like air, is a lot of different compounds. A compound is a molecule that contains more than one element. All right. An element is composed of only one type of atom. The atomic number of an element is the number of protons in the nucleus. If you look at a chemical chart, it's based on the number of protons first and foremost. They call it the atomic number of the chemical. That means how many protons does it have. Periodic table of elements lists all the types of atoms or elements known to mankind, and a molecule is the result of joining of two or more different types. Okay, most substances can exist in three states: solid, liquid, and gas. Think about water, where you've seen ice, you've seen flowing water, that's a liquid, and you've seen gas, steam, right? Okay. Here's that table of elements. You notice the atomic number is the number of protons in it. And then it has, the thing that's important to us, though, is the valence electrons, because that decides something for us. Take a look. See, you'll notice all these over here are 2 on the far right. Most of the ones in the middle are 1 and 2. And the ones on the far left column are 1, 2, and a few of them are 7 or 8. Like fluorine is 7, and sulfur is 8, argon is 8, krypton is 8. Gotta love krypton, right? Okay, and what does that mean to us as electricians? Well, the three principal parts of the atom, again, are electron, neutron, and proton. This shows you kind of, not a very good picture, of the size of these things, because this is totally out of whack. Electrons, this just is not a good representation of size, but this is kind of an attempt at that. And we want to remember that the electron has a negative charge, protons have a positive charge, and neutrons have no charge at all. So we want to talk about the atomic structure some more. And there was a guy by the name of Bohr, and he did some work with another guy by the name of Rutherford, and they came up with the atomic model. And this model says that it's got these circles, and it has electrons going around the outside of all the neutrons and protons, right? And only the outside shell is called the valence electrons. These on the outside are called valence electrons, and they are what we call free electrons because we can knock one off and send it to another element and knock one off there and push it on down the line another one. So if you had a tube, let's say you have a conduit, a piece of pipe that is full of electrons, okay, and they're pushed so that each of them is touching each other. And if I take one more electron and I ram it in there, what happens on the other end 2 miles away? One pops out the other end, right? Okay, that's how electrons really work. So the actual electron movement is actually very slow, but because they're so close to each other, when you push one, you push all, more or less.
It's called a Hopf theory, right?
Okay, so electrons are located in the outer orbit of the atom. And for instance, a copper atom contains 29 electrons and has one, only one, in the outside, the valence shell. Electricity is the flow of electrons, we know that. And once again, it's like a pipe. You shove one, you shove the whole group of them, and one pops out the other end. This is what happens. Free electrons knock one each other off its orbit to the next one, to the next one, the next one. This process is repeated many, many, many times to create electrical flow. And as I said, the electron actually moves very slowly, but the reaction of pushing one across 2 miles of packed in electrons happens very quickly, like at the speed of light. Okay. Now, we know that one bounces off, goes to the next one. And I want to go back. Hang on one second. And this is called a conductor. When we have 1 or 2 electrons in the outside shell, we call this a conductor. So 1 or 2 electrons in the valence shell is a good conductor. Not just a conductor, but a good conductor. And I'm going to talk about that some more in just a second. Whoops, too far. Then we have semiconductors. Semiconductors are materials that are neither a good conductor nor a good insulator. Okay? They contain about 4 valence electrons. I say about because it could be 3, it could be 5, and it would be considered a semiconductor. And the reason I say this is I want you to realize that this is a simplification, because what does this depend on? Whether something's a semiconductor or not, or whether it's a conductor. Our definitions that we've learned in the first chapter tell us that voltage is the differential pressure between one end and the other, right? How much pressure is being put on them to move, right? That's what voltage is. It's electrical differential pressure, right? Well, at 25 volts, something that has 4 electrons is a semiconductor. It might even be considered an insulator. Okay? But let's take rubber. Now rubber isn't not on this list at all. Let's go next to the next one. Insulators. Insulators resist the flow of electricity. Resist the flow of electricity. That doesn't mean they stop it completely, but they've got 7 or 8 valence electrons. Examples of insulators are rubber, plastic, glass, and wood. Now rubber's on that list, and I'm so glad it's there because in high voltage work, we call rubber tape semiconductor tape. Why is that? Because at 5,000, 15,000, 25,000 volts, rubber conducts pretty well. We call it semiconductor tape, really. Okay, because things change under pressure. And you need to realize that. So, now you know though, the basic theory is that it's a better conductor if it only has 1 electron. That's the best. The far end, the most resistive to flow is if it has, what, 8 electrons? Okay. And in the middle, we have the number 4. So it's easy to remember. 1 or 2 is a conductor. 3, 4, 5, in my opinion, is a semiconductor. And 7 or 8 is supposedly an insulator, except that look at rubber. Remember, rubber is supposedly an insulator. And in low voltage, it's a pretty good insulator. But extremely high voltage, it's a semiconductor. It's going to push them along. All right, that's all there is for this slideshow. Now we're going to go to the slideshow by Stephen Herman, and we're going to talk a little more about a few other things. Let me pause this.